Students, to the physics class of class 10. We are studying chapter number 1, okay, under that turning forces. Last we had studied about couple, now center of gravity. Remember, we had observed that when we lift a heavy weight with our right hand, we have to lean towards the left in order to keep our balance. Similarly, we have seen that a porter, while carrying a heavy load on his back, has to lean forward. To understand why people have to bend to carry heavy load on their backs, we'll first understand the concept of center of gravity. We all know that all bodies are made up of a small particle known as molecule. This relative position of molecules with respect to each other are fixed. We know that Earth attracts every particle towards its center by the force of gravity, which is equal to the weight of the particle. Remember, we know that the Earth attracts every particle towards its center by the force of gravity, which is equal to the weight of the particle. The center of a gravity of a body is a point at which the resultant of the parallel forces called the weight of a body acts vertically downwards due to gravity, no matter in which position the body is placed. Here we can say the center of gravity of a body is the point at which the body whole weight is said to act from. And the concept of center of gravity makes it easy to do calculation for objects having extended size. The algebraic sum of moments of weight of particle about the point G is 0. We can say at a resultant W equal to W1, W2, W3. As you can see that example here, we can make, I will explain you with this example. Okay, see, generally it turns out that the center of gravity is also center of mass. The center of mass of an object is that point where the whole mass of an object is said to be concentrated. The center of gravity of a body of irregular shape can be determined by following method. See, suspended the body from same point such as A. Now, the center of gravity of a body is that point at which all the body experience total gravitational pull. When a body is supported at center of gravity G, it remains in equilibrium. A uniform meter scale will balance itself at center of gravity. Some of the center of some irregular, some regular objects. Object, see, rod, midpoint, circular disc, geometric center, solid or hollow sphere, geometric center of sphere, midpoint of the axis of cylinder, solid cone at the height, hollow cone at the height h by 3 from the base, circular ring, center of ring, triangular lamina, the point of intersection of medium, parallelogram, rectangular lamina, we can say point of intersection of diagonals. Just you can see the circular ring can be from the center, circular disc, triangular lamina, rectangle, parallelogram, square, rod and cylinder. They had given you this one. Okay, so these are center of gravity as its geometrical center. If a body is suspended at this point, the center of gravity, it remains in its balanced state. It will remain on its balanced state. Okay. Now for an example, consider the motion of a body that is rotating as well as translating. We can say rotating also and translating also. You can see in this figure. Rotating also and translating also. Okay. Let the mass of irregular object be m and the net force acting on the object be F. Particle, we can say complex. So what is force? Ma. It is difficult to apply this one, mass into acceleration, but it is possible to use the equation m for the whole mass m, because the whole we can say the center of gravity be G of the object. During the journey of the shown object, G, the point G does not revolve. All the particle of the object revolves around the point G. You can see the point G. Even though it is not possible to easily track the motion, it is possible to track the motion of point G. We can use F equal to m into a, mass into acceleration. Mass means whole mass we are taking, and acceleration we can take as a center of mass G. The concept of center of mass make it easy to track the motion of an object. That is by second law, F equal to m into a, that is mass into acceleration. So center of gravity outside the body, we can say for an example, it is not necessary that the center of gravity will always within the body. Okay, you remember this one, should be outside the body also. Okay, now